Hello friends, welcome back to our YouTube channel Google Baba. We are today going to solve very important example, that is in a right angle triangle ABC, angle C is equal to 90 degree and DEF are 3 points on BC such that they divide it in equal parts. Then prove that 8 bracket AF square plus AD square is equal to 11AC square plus 5AB square. In this figure we have given this triangle ABC is a right angle triangle at C. Means angle ACB is equal to 90 degree. Now points DEF are on this BC, segment BC, and they divide, these 3 points divide BC into equal parts, means BD is equal to DE is equal to EF is equal to FC. These parts are congruent or equal in length. Now first I will write here to prove. This is our to prove. 8 in bracket AF square plus AD square is equal to 11AC square plus 5AB square. Now here AF square, here in our to prove, here AF square and AD square. So first we take here, when here AF square, then we take this right angle triangle ACF. We take this first, right angle triangle ACF, and then right angle triangle ACD. This right angle triangle ACD. First we take right angle triangle ACF, then we take right angle triangle ACD. Now in these two right angle triangles, by using Pythagoras theorem, first in right angle triangle ACF, by using Pythagoras theorem. Here when we use Pythagoras theorem in this right angle triangle ACF, then by Pythagoras theorem, hypotenuse square means AF square is equal to FC square plus AC square. Now this FC is 1 upon 4 times this total BC, because here 4 equal parts, and out of these 4 equal parts FC is the only one part and total 4 parts. So we write this FC is equal to BC upon 4, BC upon 4. Therefore after applying this Pythagoras theorem in this right angle triangle, then we get this way: AF square is equal to AC square plus FC square. Now this FC, instead of this FC, remaining we write as it is: AF square is equal to AC square plus this FC is 1 upon 4 times BC. Therefore we write BC upon 4 bracket square instead of FC. Now we here squaring this BC square and separate square to 4. Then we obtain here AF square is equal to AC square plus separate BC square upon separate 4 square, that is 16. This is our equation number 1. Now similarly we apply Pythagoras theorem in right angle triangle ACD. In right angle triangle ACD. Now look here, in right angle triangle ACD, this AD square, this is hypotenuse, AD square is equal to AC square plus CD square. In right angle triangle ACD, this way there is right angle triangle. This, in this right angle triangle we apply Pythagoras theorem. AD square hypotenuse square is equal to AC square plus CD square. Now this CD means 3 parts. Therefore, we write this. This CD is 3 upon 4 times BC from that figure. From that figure, look here, from that figure, this DC, 1, 2, 3 parts. Therefore, 3 upon 4 total part, 3 upon 4 into BC. Therefore, we put there instead of this CD, we write here 3 upon 4 into BC bracket square. Remaining is same, AD square is equal to AC square and CD square. Instead of this, we write plus bracket 3 BC upon 4 bracket square. Then squaring here. So we get this as it is, AD square is equal to AC square plus we write here 3 square is 9 and this BC square upon 4 square, that is 16, means separate square to each term, means 3 square 9, BC square upon 4 square 16. This is our equation number 2. Now adding equation 1 and 2, then left to left side and right to right side, means here left to left side means what? Here we add AF square plus AD square. These are at the left side is equal to AC square 2 times. So we write 2 AC square plus 1 BC square upon 16, 1 BC square upon 16 plus 9 BC square upon 16. Therefore, we write here this AF square plus AD square is equal to 2 AC square plus denominators are same, so we write as it is 16. Then numerator 1 BC square plus 9 BC square we write here. Therefore, after this addition of these two, first we write AF square plus AD square is equal to 2 AC square. Here 1 BC square plus 9 BC square means 10 BC square upon 16. This 16 and 10 both are divisible by 2, means 2 8s and 2 5s. Therefore, we get AF square plus AD square is equal to 2 AC square plus 5 BC square upon 8. This is our next step. Now, multiplying both sides by 8 means here we multiply to this by 8, this by 8, this by 8 and here also by 8. So here 8 cancelled. Okay, then we multiply here by 8 and put square bracket. Here 8 2s are 16, then becomes 16. Therefore, we get here now after multiplication, look here. Therefore, 8 in bracket AF square plus AD square is equal to 16 AC square plus 5 BC square. This is our equation number 3. Now we take that bigger right angle triangle, that is ABC, and in this right angle triangle ABC we also use the Pythagoras theorem. Therefore, here after applying Pythagoras theorem in this right angle triangle ABC, then AC square plus BC square is equal to AB square. That is the biggest right angle triangle. This way, here A, here C right angle and here B. So we apply Pythagoras theorem here. Therefore, AC square plus BC square is equal to AB square. Now here we take this AC to the right side, then that becomes minus, means BC square is equal to AB square minus AC square. Now we put this value of BC square in equation number 3 at BC, means here. Then we get here, look here properly. Therefore, see this. I have taken this AC square to the right side becomes minus and we put this in equation number 3. Then we get here Look here properly. 8 in bracket af square plus ad square is equal to 16 ac square plus 5 in bracket ab square minus ac square. Then we multiply to this bracket means ab square minus ac square by 5. Therefore, we get here this as it is here means 8, then square bracket af square plus ad square is equal to this 16 as it is 16 ac square plus 5 into ab square plus into minus this plus into minus, that is minus 5 into ac square. Then here as it is we write below, therefore 8 in bracket af square plus ad square is equal to, now 16 ac square minus 5 ac square means 11 ac square, then remaining this plus 5 ab square. This is our to prove.